3.
Hey, what's up, guys? Welcome back to Shields University. Today, we're gonna work on a Edwards Engineering zone valve, which is right over here. Can you zoom in on this? It's a 3-wire zone valve, and we're gonna show you how to wire it with the Ecobee. And if you go wire it with an Ecobee, I'm pretty sure it's simple enough to wire with the Nest. So we had a subscriber request a video on how to wire this zone valve to the Ecobee, because usually these zone valves are wired with a 3-wire thermostat. It's not your conventional thermostat. So we're gonna explain and give you the tutorial on how to make that happen. So safety first. So most importantly, you're gonna have somewhere in the mechanical room or boiler room, you're gonna have a power on-off switch to the equipment. Disregard this Honeywell board and these terminals here. So today we're using the transformer, thermostat, rib relay, and the zone valve. So in our case, we're just gonna plug this off while we work on it. You're gonna have a on-off switch somewhere. Make sure you turn it off, and then make sure you have a meter, and you can check for the 24 volts at the transformer. So you have no volts. I can show you once we turn it on what we're gonna read. 27 volts, 0 volts. Also gonna 1 and 3 to the zone valve is basically 24 volts. Zoom in a little bit. This here is number 2, which is empty. It's blank. There's nothing goes there in this application. So okay, let's start from scratch. This is basically what you're gonna see when it's wired, and right now I'm gonna remove everything. Okay, so let's see. Let's start from scratch. I'll just explain what's what. This here is your 3 wires from the thermostat, and this is basically these 3 wires here are coming to this thermostat here. So you have the white wire, white wire is for W. It goes to W here. I'm using green for common and R to RC. Okay, so that's pretty easy. I have other videos on how to install the Ecobee. So green for common, white for W, and R to RC. And if you're using, for some reason, Ecobee, if you're using only one R, you go to RC. If not, it won't power up if you go straight to RH. I gotta call Ecobee and see why they do that, but that's how they do it. For Nest, you go to RH. Okay, so now that we got that out of the way, just make sure you label it. Thermostat wire, in your case, trace it. This here is your transformer wire, power. So if you can see, I'm pulling here. That's where it goes. Let me just show you a quick continuity test. So right now, since this is wired to the transformer, and with the power off, you would go to continuity, and you would have that if you have a decent meter. Let's say we take off the common on the transformer. You're breaking continuity, so you won't have that continuity there. Some meters, it's just going to give you 0. It's not going to give you the ring. So you can test your wires like that with the power off. You can, for instance, if you want to test the thermostat wires, you would connect the red and white at here with a wire nut, and then test the continuity from red and white here, and it would ring, or you would have 0 when these are connected together. Hopefully you get the idea. If not, you can comment and ask me some questions, just in case you don't know what's going where. That's how you figure that out. So thermostat wire, this is the transformer wire. So then we have our rib relay. This way. Okay, zoom in here. We have 1 and 3 is power, 24 volts. It says it right here, 24 volts. You have 4, 5, and 6. And here it says 4 to 5 opens this valve. So if we have power to 1 and 3, if we connect this power here to 1 and 3, and we have constant power going to this valve, and I come here and I bypass 4 and 5, the valve will close. Sorry, if I bypass or use a small jumper to go to from 4 to 5, this valve will open, and you can see this little shaft here. It's gonna turn. You're gonna see it turn. It turns very slowly, but you're gonna see it, and we're gonna show you. So, and then if you go and you jump 5 to 6, like it says here, can you give me a second? Let me look at it again. 6 to 5 closes valve. Okay, zoom in. So 4 to 5 opens valve, 5 to 6 closes valve. It tells you right here. So basically 5 is the common. So if you bypass 5 to 6, it closes. 4 to 5, it opens. We're going to show you. So the key here to make this work with the Ecobee is this relay. If you don't have this relay, you're not gonna make this work. You're gonna break your head. Unless you get a 3-wire thermostat, but those are conventional thermostats. They're not smart thermostats, basically. So here we go. Let's start wiring this guy out. So we're gonna go, I think, let's start with the transformer. We go red, it says there. This is R, basically, from the transformer. Go right there, number 1. This is common from the transformer. Going to 3. Okay. And then we're gonna go with the thermostat. R. Try to keep it uniform, color to color, color to color. So this is the thermostat wire, R to RC here. Green, it's going to be common. Back to the thermostat, it's common. Next step, the W. The W is what's going to energize this relay on a call for heat. Remember that, it's very important. W will energize this relay. And zoom in here. If you read this, white and black is 120 volt. We're not using that. So white and black, we cut it and we tie a wire knot on there. It's not gonna be in use. White and blue is for 24 volts VAC, or you can use it for DC, but we're gonna use it in 24 volts AC in this case. So this white and blue will be used to energize the relay. So you wire nut that together. Get that out of the way. Now, in order to complete the circuit for this, the common is white and yellow for this relay. Zoom in here. So we're using white and blue, and white and yellow is common. So this wire has to go back to its home, and common is right here. So if it makes it easier to go to the zone valve common, you can do that. If not, you can go back to the transformer common. It's the same thing. Then, so these are done. This is the tricky part. Zoom in here. Blue, normally closed. Yellow, common. So let's wire yellow first. Yellow is common. Remember I said 5 on this valve is common? And then here's where it's a little tricky to explain. Whenever a relay or valve or whatever you have, electrical component, whenever you're not applying power to it, that's when it has a normally closed or normally open switch. So once you energize it, it switches positions. So when it's de-energized, it's when it's normally open or normally closed. So right now it's on its natural positions, or normally open or closed. So we want this valve, well, most applications, I would say 99% of applications, you want this valve closed. Unless the thermostat calls for heat, then you want it to open. So we're gonna have blue. Since it's normally closed, we're gonna go to 5 and 6. So this is gonna be constantly, so because this is normally closed, you see the switch? Zoom in. Yellow and blue, the switch is closed. So right now we have continuity from here to here. Let's prove it. See? Let's see. Well, they both have continuity. Well, actually, you know what? Continuity, because that switch is normally closed. Now let's do continuity between yellow and normally open. Nothing. So if I was to energize this switch, this switch will actually be closed now from the normally open. So I'm hoping you guys get the idea. So right now, just remember 5 and 6 are going to be normally 5 and 6 are going to be normally closed. So this actuator is going to close your valve. It's going to be closed unless a call for heat from the thermostat comes on. Orange is going to go to number 4. And there we have it. So these are key. Yellow and blue, 5 to 6. Yellow and orange, 5 to 4. Now let's energize the thermostat. There it is. Show them the before. You see this? The shaft, it's closed. Come here. It's set to 66 and it's inside here, it's 74. So we're gonna raise the temperature. See the relay? So right now, the thermostat is telling the relay to energize, and then it's gonna change the positions of these switches. So look at that. So this is just the power head. It's gonna be tied into a valve, and right now this would be turning the valve, the valve stem, and it's turning the actual valve in the piping. Slowly opening. Is it still spinning? It looks like it's really slow. So right now, when you see the rib relay energized, if you wired it correctly, it would be opening your valve, and you would get hot water, wherever the pump is coming, is whatever pump is wired. It's going to be pumping through circulating through the valve and heating your space. So it's open. So it should stay there. It's going to be circulating hot water from the boiler to your space, baseboard, radiators, whatever you have, and then it's going to come back to the boiler to the return. So now let's say the space hit temperature. Let's lower the thermostat and de-energize. So now it goes back to your normally open and closed positions. And now you have your valve. It's going to start closing slowly. So I spoke to the engineer and the manufacturer, and it's important you never apply power to 4, 5, and 6. It's just dry contact, so you're not using any power to these. You'll blow the fuse, or at best, or basically damage the motor in there if you apply power to 4, 5, or 6. The only power you need is 24 volts to 1 and 3. So it's closing there slowly. So there you have it. You see how it closed? Just so you can see the power that you're going to read. .28 volts. Same thing as here. Read the meter, Liz. 28 volts. And whenever there's a call for heat, you'll get 24 volts from the W into here and back to common. Okay, guys. So let me know if you have any questions. I mean, I don't think many people have this valves, but hopefully it helped the subscriber who requested the video. Let me know if you have any other valves or any other components you guys need help with. Remember to shut power off before you work on anything. And let me know if you have any questions. Thanks again for joining us.